Now, the third scheduling algorithm in the non-preemptive category is priority. Priority CPU scheduling algorithm. We can understand the concept of priority on the basis of very simple example. Let us consider an example. When you are watching a movie on a laptop and you have not plugged in the power source, your battery is going critical. So, will the system first show you movie, or will it first tell you that your battery is going to be drained? Plug in first. So, it first shows the important things, the important processes, and then the less important ones. So, plugging in the laptop is a more important process than watching movie. This brings in the concept of priority, which were not available in the previous FCFS or SJF. Let us now consider it with an example. With the same example but with the priority column included. So we have the 5 processes P1, P2, P3, P4 and P5. We have the arrival time at 10 seconds and then at 12 and 15. Also we have the burst time at 4, 3, 4, 3 and 1. Now we assign priority 4, 1, 2, 3, 4, and we have to calculate the waiting time and the turnaround time. Now there's no convention regarding priority, so either you can consider the highest number as the highest priority or the lowest number as the highest priority, but you have to mention it first on your copies that you are taking it 1 as the highest priority or 4 as the highest priority. In my video I am taking 1 as the highest priority, so I mention it taking 1 as the highest priority. Now at time t is equal to 0 seconds, we have no processes and the CPU is idle. Now at time t is equal to 10 seconds, we have 3 processes, namely P1, P2 and P3, which have the burst time as 4, 3 and 4 and having the priority of 4, 1 and 2. We see from here that P2 is assigned the highest priority as it has been the priority 1. So now we make the Gantt chart. For the first 10 seconds, the CPU was idle, and after 10 seconds, P2 is executed for 3 seconds, which goes up to 13. After that, at t is equal to 13 seconds, we have again P1, P3 and P4. P1 has the burst time of 4, P3 has the burst time of 4 and P4 has the burst time of 3. Now the priorities assigned are P1 has the priority of 4, P3 has the priority of 2, and P4 has the priority of 3. Now we see that P3 has the highest priority among these. So we select P3 and it runs for 4 seconds up to 17. Now at t is equal to 17 seconds, we have P1, P4 and a new process is introduced, that is P5. Now P1 has the burst time of 4, P4 has the burst time of 3 and P1 has the burst time of 1. Now P1 has the priority of 4, P4 has the priority of 3 and P5 has the priority of 4. Now as we can see that the highest priority is P4, so we select P4 and execute it for 3 seconds and it goes up to 20. Now at t is equal to 20 seconds, we see that we have P1 and P5 with the burst time of 4 and 1 respectively and the priorities as 4 and 4. Now both have the same priority, so we can select either the FCFS or the SJF, but we have to mention it first that we are using FCFS or SJF. In my case I am using FCFS, that whichever process is first in the ready queue is executed first. So here P1 is executed. It runs for 4 seconds and goes up to 24. Now at time t is equal to 24 seconds, we have only a single process P5 having the burst time of 1 and the priority of 4. Since it is a single process, so we select and execute it. Now P5 is executed for 1 second and goes up to 25. Now for calculating the waiting time and the turnaround time, we have the similar formula, that is waiting time is equal to the starting time minus the arrival time. Now first P2 was started, so the starting time of P2 is 10 and the arrival time is 10 as well, so the waiting time is 0. Next P3 was started at 13 seconds and the arrival time is 10, so the waiting time is 3. After that P4 was started at 17, so 17 minus the arrival time 12, that is equal to 5. After that P1 was executed at 20, so 20 minus 10, that is 10. And after that P5 was executed the last at 24 seconds minus the arrival time, that is equal to 9. Now we have to calculate the turnaround time. We can calculate the turnaround time in a similar manner, which is burst time plus the waiting time. Now here the burst time is 4 and the waiting time is 10, that equals to 14. Here the burst time is 3 and the waiting time is 0, which is 3. Burst time is 4 and the waiting time is 3, which equals 7. Here the burst time is 3 and the waiting time is 5, which comes out to be 8. Here the burst time is 1 and the waiting time is 9, which comes out to be 10. Now we calculate the average waiting time. So we add up all the waiting time and calculate the average. Divided by the number of processes. which comes out to be 5.4, and the average turnaround time by adding all the turnaround values divided by the number of processes, which is 5, and it comes out to be 8.4. The biggest advantage of the priority CPU scheduling is that the important processes are executed first rather than the non-important processes, which make it a very important CPU scheduling algorithm, and it is used in various important operating systems.